Math 7 students, we're going to start with Chapter 6, Lesson 4 notes. This is found on pages 469 to 472 in your textbooks. Make sure that you have your template in front of you. Notice that we are going to look at two-step equations today, and there's a couple steps that I want you to follow. The first step being to rewrite any subtraction if you have it. Step 2, you're going to get rid of the constant term that is on the same side as the variable. And that is the same as our one-step equation process. Step 3 is really the new process where we're going to get rid of a coefficient in front of the variable. Let's take a look at example 1. So example 1 says 13x plus 42 equals 81. If you'll notice, we have two things to get rid of on the same side as the x. The x is on the left side of the equal sign. We have this plus 42, that's our first step that we're going to get rid of, and we have this 13, which is our coefficient, that's our second step to get rid of that. In order to get rid of plus 42, we're going to subtract 42 from both sides. And that's not new because you did that in the prior lessons with one-step equations. So I'm going to draw my line. 42 minus 42, these zero out. And on the right side, I get 39. And on the left side, 13x is still left. Now my second step is to get rid of that 13 in front of my x. And you may remember from one-step equations that there's multiplication in between these two. So to get rid of 13, we're going to do the inverse operation, divide by 13 on both sides. When I do that, the 13's cancel. They're really just a 1, and we get x equal to 39 divided by 13, which is 3. We're going to put our answer in set braces, and then we're going to do the check. So we've got our original as our first line of our check, 13x plus 42 equals 81. In the next line, I'm going to plug in what I got. I got 3, and everything else stays the same. In the next line, we're going to do order of ops. We need to multiply before we add, so we're going to do 13 times 3, which is 39. And we're going to add it to the 42 in the next line. When we add 39 and 42, we're going to get 81. And 81 equals 81, so check mark, you're done. In example 2, we do have some subtraction we can rewrite. This subtraction right in front of the x over 2. The way I'm going to do that is I'm going to leave the negative 3, leave the negative 10, change this to a plus sign, and because it would look a little weird to put the opposite in front of the x in the numerator, we're going to instead put the opposite or the negative in front of the 2 in the denominator. Remember, that makes this whole thing negative. So I'm really rewriting the subtraction here. The next thing is, if you look at the right side of the equal sign, we've got a negative 10 as our constant, and our constant is what we need to get rid of first. So in order to get rid of negative 10, we can do one of two things. We could do minus negative 10, or for a cleaner kind of step here, we also could add positive 10. And the way I know that is, I want to zero out negative 10, so I need to add something that will make it into 0, and negative 10 plus 10 gives me 0. Negative 3 plus 10 gives me 7 on the left side, and we still have x divided by negative 2. Now we want to get rid of that division of negative 2. We can multiply each side by negative 2, and that will get rid of these. Negative 2 times 7 gives me negative 14 equal to x. And we're going to put that in set braces. Let's try the check. So I've got my original and my plug-in, and then following order of ops, I'm going to clean up this negative 14 divided by 2 first. So that leaves me with minus negative 7. And that's the same as saying negative 3 equals negative 10 plus 7, which gives me negative 3. So that checks out. Let's try example 3. This one does not look as long as the prior examples, But the reason that it's a two-step equation is because when you rewrite the subtraction, we've got a minus x here. That becomes plus the opposite of x. And even though there's not a number as a coefficient on this x, you could still squeeze in a 1, making this 6 plus negative 1x. Remember, when there's no coefficient in front of a variable, it's automatically 1, and this negative makes it negative 1. Now, let's line up our attack. We need to get rid of the constant on the same side of the equal sign as the variable. That's 6, so to get rid of 6, we're going to subtract 6. These zero out, and I get 4 on the left side equal to negative 1x. Then I need to get rid of the negative 1 being multiplied by x, so I'm going to divide both sides by negative 1. 4 divided by negative 1 gives me negative 4, and we're going to put our answer in set braces. Try the check. So I've got my original 10 equals 6 minus x, and then I'm plugging in a negative 4. I had a minus a negative, so I cleaned that up in the third line down and rewrote it as 6 plus 4, which gives me 10. On the last one, example 4, we have no subtraction or rewrite, so the first thing we want to do is get rid of the 4 on the left side. So to get rid of 4, we're going to subtract 4 from both sides. 4 minus 4 zeroes out, and that's what we wanted. 1/5 times x drops down. 1 minus 4 gives me negative 3. Now I need to get rid of times 1/5, and we want to do the inverse operation, which is division. So I'm going to divide both sides by 1/5. The 1/5 divided by itself gives us 1, and x drops down. Negative 3 divided by 1/5 is the same as negative 3 times 5 if you do keep, change, flip, which gives me negative 15. We'll put that in set braces and we'll do a check. Got my original and my plug-in, and now I'm going to do the multiplication first. So 1/5 times negative 15 gives me negative 3, and 4 plus negative 3 gives me 1. 1 equals 1, so you know your answer's correct.